Let's do an example finding velocity from a graph. This is a linear graph, obviously. um, the cool thing about that is it makes it really easy whether I'm finding the average velocity or the instantaneous velocity. The instantaneous velocity is the slope of the tangent line. I don't know if you can see this well enough. If I drew the tangent line at any one point, it would be the same as the tangent line at any other point along the line. And that means that it has the same slope everywhere. But we can use the average velocity expression. The average velocity is delta x over delta t. And since it's the same everywhere, I may as well choose the entire delta x and the entire delta t. So if I do that, the delta x is on this scale would be, oh, let me write one more line. The x final minus x initial, and the t final minus t initial. And in this case, like I said, I'm going to go for the whole entire range of the motion. So the whole entire range of the motion would be x equals 30 meters, and of course it goes all the way through 0 on the bottom. And then the t would be the 10 seconds and 0 seconds on the bottom, and so I get 30 over 10 is 3 meters per second. If you remember what the equation of a line is, that's also given up here, that x equals 3t. And so if you remember, it's usually the one thing in physics, usually in your math class, you learn y equals mx plus b, whoops, plus b. But now we're doing x as a function of t. So that means the y gets replaced by x because the x is the thing on the vertical axis, and the x gets replaced by t because the t is now the thing on the horizontal axis. So your equation y equals mx plus b could also be written for this example, x equals mt plus b. M is the slope, and it's given right in the equation of the line that m is indeed 3. And it has to be, since you're going to multiply it by t time, m has to be meters per second so that the seconds will cancel and you'll get meters on the x-axis. Also, as I mentioned, even though I did the average velocity, this exact same thing as the instantaneous velocity. The instantaneous velocity is the slope of the tangent line. And as I mentioned, the tangent line is exactly the same as the line we just found, which is the same as the line. And that's what we just found the slope for.